Hi everyone, this is Joel from 8400 Lights, and today I thought I would go through the process I'm using to convert RGB floodlights for use in a computerized lighting show. So here's an example of one of the lights that I've been buying off eBay, and I've been getting these for about $6, maybe $7 a piece, so not too bad. As you can see, they come with this 110 volt power cord, and then they're controlled through an infrared controller similar to this one here. And these have a number of other effects in them as well: flash, strobe, fade, etc. So the first thing I want to do before anything else is I really want to make sure that this unit is working properly. So I'm going to go ahead and wire this up into a 120 volt source. So I've just taken an old plug from an old string of lights here and wired this onto our 120 volt feed. Plug that in, and as you can see, it starts going through its little patterns. And again, I can use this infrared remote to control this. And say, give me red, give me green, blue, white, turn it off. So now we know that the unit is working as designed before we start to do anything. So the next step that we want to do is we really want to take some measurements of the various voltages for the red, green, and blue off the chip itself. And we're going to do that and start to disassemble the unit. Now I will caution everybody, this is still plugged in, so we want to be a little bit careful. But we can see here that this top housing is held in place by 4 different screws, and then we can also see the little infrared sensor right here as well. So we're going to start by removing these 4 top screws here. So I have all 4 of these screws undone now, and again this plate just lifts right off, and we'll set it aside. Now we can see this glass plate here. This just lifts off. Sometimes you will see this silicone seal on the back side of it, silicone gasket that will come off. Sometimes it's a little bit stuck to this plate. Sometimes it comes right off. Either way, we can take that off. Set that aside. So now we can see the silver reflector here. And in this particular case, we can see our IR sensor and the fact that they have cut a little notch here for the IR sensor to come through. And the reflector plate is held in by 2 screws. Sometimes there's 3. This one has 2. So we'll just go ahead now and take these 2 screws off and take out this reflector plate. Okay, so I've taken off the 2 screws, and this reflector plate will just come right out of here like this. Now as we can see, they notched the plate to get the IR sensor through, and oftentimes what we do if we turn it over, we can see they just left the piece here. So I'll actually take and fold that back down into place and restore a little bit of that reflector. Just kind of smooth that out like that. We'll set that aside. Alright, so now we're getting our first really good look at the chip with our 10 watt RGB chip soldered onto it. So we can see here some of the control circuitry used for the various effects and for controlling the IR. And then we can see the RGB chip itself and how it's soldered onto one common side here, and then we have 3 leads on the other side here. So what we want to do now is take some measurements from this side of our RGB chip to this side of our RGB chip so we can figure out which of these leads are which for our different colors and their various voltages. So I've placed a piece of black electrician's tape over the LED for the moment, just so that we don't blind ourselves as we do this next part of the testing here. So I'm going to go ahead and I'm going to turn on the unit, and I'm going to set the color to blue, which is hard to see because the tape's in the way. And then we're going to measure the voltages across each one of these points here. It's reading 0. This is 6.1 and 9.46 there. Now we'll do green. We'll start here. We get 1.63. $9.14, and basically nothing here. And we'll do our red. We get 6.25, a whole lot of nothing, and nothing there. So what does that tell us? Well, we saw 9 volts here off this connection when we returned to blue. We saw 9 volts here off of this connection we returned to green. And then we saw about 6 volts off of this connection when we returned to red. So this is pretty consistent with what we know about 12 volt RGB lighting, in that the green and the blue, I should say, typically run around 9 volts or so, while the red typically runs about 6 volts or so. So the red typically runs a little less voltage than blue and green. Now on a 12 volt lighting control system, you can expect to lose a little bit of voltage just based on how DC current works. So this being 9 volts apiece doesn't concern me, but we'll have to do something to address this red being only 6 volts. So now what we're going to do is we're actually going to finish disassembling the rest of this housing, and then we'll start to actually work on rewiring this chip itself. So I've gone ahead and unplugged it and disconnected our little plug-in here, and taken our tape off the front of our RGB chip so we can see that again. We're going to turn our attention to the back side of the unit now. And here we have a little compartment that's again held into place by 4 screws. So we're going to go ahead and take these screws apart. Okay, so I've removed all 4 of these screws, and we'll open this up. And here we can see that we have our driver unit, and in this case we have a ground wire that actually does connect to the case. It's not uncommon when you open these to find out that this ground wire is just hanging in space. It's not connected to anything, which is really bad, but in our case it's not necessary. We're not concerned about it because we're going to replace all this wiring anyway. So we can go ahead and cut all of this out as it's going to be discarded. And then we'll just go ahead and cut this out as well. We can toss it, it's garbage. And then we'll just go ahead and pull this electrical wire out the back, like that. And this will give us a nice opening here to run our new wiring. So now what I'm going to do is I'm actually going to disassemble the circuitry on this chip. And I do this for a couple of reasons. One is I want to look for a clean attachment point for my new wiring. Now I could use these 3 points here that we've identified as being an attachment point, but my soldering is not the best in terms of a skill level, so I'm really fairly concerned about unsoldering and resoldering these connections. What I'm hoping to find is an attachment point on the circuit board somewhere that I can use to tie into these particular points. There's got to be some kind of a pathing between these points and some point here in all this circuitry. So I'm actually going to disassemble all of these components. Now with these particular boards, these components here are nice because they're actually not through the board, they're just surface soldered onto the board itself, so I don't have to worry about pins or anything like that. So I'm going to go ahead and start to disassemble the board now. We'll start by taking off the IR sensor. Then you'll notice I've pulled the power leads through. So we'll just go ahead and quickly unsolder those. Now what I'm going to do next is I'm going to actually go around and unsolder these various resistors and components we see on the board. I'm going to leave these big ICs for the moment. And again, I want to do this so I can try to find another attachment point for my new wiring. I'm also going to do this to prevent any flow of electricity back through some of these circuits and lighting up other parts of the chip when I don't want them to, which I've seen happen. And what I've found is if I very quickly heat both sides of the component, I can actually use the tip of the soldering iron to lift them off. But you don't want to heat it too long and end up damaging the board itself. So here is our circuit board now that it's been cleaned of all the various components on it. What we want to do at this point in time is a little bit of research and see if we can identify the points to which we can attach our new wiring without having to break these existing soldering joints on the RGB chip itself. So I don't want to really break these. And I know from this electronics there has to be some kind of a circuit path that goes from this point here, which we identified as our blue, to one of these different points somewhere on this board. So we're going to use our voltometer again and just look for some continuity traces that we could utilize. So now that we have all of our components disassembled off the chip and we've done our testing to determine what points to use to attach our new wiring, we're going to go ahead and start adding our new wires and rewiring this. So we're going to begin by taking the chip out of the housing here, and again it's just held in by 2 screws into the base of the housing, and we're going to go ahead and remove those screws. So when we take this chip off the housing, it's not uncommon to have a little bit of dielectric grease on the back side of it for thermal properties, which is fine. And we're going to go ahead and just clamp this chip into our little soldering station here in preparation for the new wiring we're going to add. So for the new wiring, what I've been using is, it's actually called alarm cable. It's a 4-conductor 22 gauge wire, and some might say that 22 gauge is a little small for this application. I really haven't had any problems with it. If I was going to do something of a larger size, like a 20 watt or 30 watt floodlight, I definitely use a larger gauge wire, but I've had pretty good luck with this 22 gauge wire so far. So I'm just going to take and strip off probably a good foot or so of this outer jacket. So again, here we have 4 wires. We've got a blue, we've got a black, we've got a red, and we've got a yellow which we can connect for our green. So I'm going to take now and strip off just about 1/8 of an inch or less off the end here. So here are my 4 wires where I've stripped off the ends. Again, I don't need a long amount of stripped wire here. Shorter is better in this case. So one of the things I like about these cases that these floodlights have been coming in is if we look at them, we can see that there's two holes here that actually go all the way through the case. So we can use these holes to run our new wiring, and we can run our black common through one side of the case, and then the three color wires through this other hole in the case. And that puts them on opposite sides of our chip for resoldering. So that works out rather nice. So now let's go ahead and resolder these wires onto our chip. So here I've mounted our chip into our soldering station, and I've placed our blue wire here on that L point that we had identified earlier as having a wiring path to this point here on our RGB chip for our blue color. So we're going to go ahead and solder this into place. And now we'll go ahead and solder our green wire into place. And now finally our red wire. So now we have our three new control wires soldered onto our chip for our blue, green, and red light. And now we're going to solder in our neutral. So this is how our rewired chip currently looks. We have our neutral line here. We have our power for our blue light here. We have our power for our green light here, and the power for our red light sitting underneath this clip right here. So now we can go ahead and begin to reassemble everything. Alright, now we're going to go ahead and start to reassemble everything. I'm just going to take these three color wires and put a little bit of a bend on that so that it lines up nicely with this hole, and start to pull these back through. So our chip fits down in there again. And then we'll reassemble the screws. Once the screws are back in there, the chip is held down again, we'll go ahead and put on the reflector. Our reflector is back in, so now we'll go ahead and continue with the front lens and the silicone seal. So again, if this seal comes off, it's not a big deal, it's just kind of stuck here now. The silicone gasket here actually has a little bit of a lip on one side of it and a flat surface on the other. You want to make sure that the side with the lip goes in this channel here on the edge of the housing, and that's what helps provide our watertight seal. So we'll put that in along with a piece of glass, and then we'll put this top frame in and screw down the 4 screws. So here is our reassembled front side of the housing again, good as new. So let's turn our attention onto the back. Now you may be asking, why did I leave so much length here in the back? And there's really 2 reasons. So depending upon the controller that you're going to use, if you're going to use a 12-volt controller, it will more than likely put out 12 volts on each of these wires. So if we don't do something to reduce the voltage on the red line, we'll actually burn out the red LED. So part of the reason we left so much open wire here is we're actually going to solder in a resistor here. So I'm just going to take and cut this wire. Now these are some 18 ohm 1 watt resistors that I purchased, and we're just going to solder one of these in this break on the red line here that we just created. And this will take care of dropping our voltage off down to a level that the red set of LEDs can tolerate. So before I do that, I'm going to cut a couple of small pieces of heat shrink tubing and put those on either side of the red wire here so that I can have some insulation on this once I solder this in. Now these resistors come with some fairly long leads here, so I'm just going to cut this lead down because I don't need this much of a lead. Clamp this in my soldering station. I'll trim this lead off here. And the other side. So now I'm going to go take and put my shrink wrap tubing there as my insulator, and I'll go shrink that down. And here's what it looks like when I've shrunk that tubing. So now that's nice and insulated. So the other reason that I've left all these wires so long back here is that should something ever happen to the LED chip, I've actually got enough slack that I can disassemble the front side of that and pull that whole chip and board forward some and actually replace just the LED chip on there if I wanted to. So that's what this extra slack is for. Alright, so now let's go ahead and reassemble this whole backside unit. We have our cover here, and again we have a silicone gasket on that as well. Like the other gasket, this has a flat side to it as well as a ribbed side. I want to make sure the ribbed side goes into this channel here on this cover plate. And then again we have this port here from the old electrical that we will just run our new wiring out through. Like this. And then we just tuck our wiring in. Now it's important to make sure that this gasket is fitting properly on here so that we're not pinching the gasket in any way, we're not pinching any wires, and that everything is going to provide some watertight seal. So once we have that done, we'll go ahead and add the 4 screws back in. Alright, so we have completed reassembly of the floodlight. Looks exactly like what we had before, except now we have a different wire coming out of it. If you notice that this wire is not quite as big as the one that was in here originally, so we have a little bit of a gap here on this port, and I'll just go ahead and fill that with some silicone here in a minute. So now the only thing left to do is to put on your favorite style of connector. So we'll go ahead and do that next. I've been using these little JST connectors myself personally. There's a lot of people who will say, yes, but these aren't waterproof, and I would agree with that they're not. But as we always say, it's not so much that water gets in, but can you give it a path to get back out again? I've had really good luck with these. I know a lot of people, though, will use the round 4-pin watertight connectors as well. But I'm going to solder one of these on to the end of this for my purposes. Alright, so here is the end of my pigtail coming out of my light, and I've stripped off a little bit of each of these ends. And we'll now solder this to the JST connector. However, before I do that, I'm actually going to take and slip on a large piece of heat shrink tubing over the outside edge here. And then on my JST wires, I'm going to slip on 4 smaller pieces of tubing. 1, 2, 3, 4. I'll just tuck those down so they don't get in the way while I'm soldering anything. There I have my 4 connections soldered together. There I've just slid the heat shrink tubing down over each one of my wires, and I will go heat that up and shrink it for insulation. I've gone ahead and shrunk down not only those 4 smaller tubes, but also the larger one on the outside. So now the only thing that's left to do is to plug this in and give it a test. So now I just have to plug this in. I've got this wire running from my controller, and I've got a little RGB test sequence going. So we'll plug this in, and look at that. We get all three colors. So again, this is Joel from 8400 Lights, and I hope you enjoyed this video of how I've been rewiring these little RGB floodlights for use in an animated Christmas display. Thanks, and see you soon. Bye-bye.